Okay, so today I'm gonna be solving yesterday Leetcode daily. It was the previous. It is similar to the previous one. I guess this one I recorded the solution for this one, and it seems like the current one is it's pretty interesting in terms of it's very similar, and I found it very kind of interesting to solve it because like the previous one, this one I checked the solution, and this one I was challenging myself to solve it. So might be a good exercise for you if you wanna improve your skills. Like first, try to solve this question, maybe look up the solution, and then as a home exercise, do this one. So the idea for the solution is the following. So we have fences array, and basically H fences and V fences, and I should find the maximum square maximum square area that can be obtained by removing fences. So let's check this current problem. So the input for this one is like H fences. Fences is like 2 and 3, and V fences equals 2. So the grid is for following. By default, we are assuming that there are like fence at index. So horizontal fence is gonna be at M, and the vertical fence is gonna be at N. So the so by default, like those fences already exist, like 1, 1 here, and then N, M, and then the input is V fences, so at 2. So here N is equal N is equal 3, and then M is equal 4. So we have this one vertical one, a fence at 2, and then you have 2 horizontal fences at 2 and at 3. So, and the question is, like, by removing vertical and horizontal fences, is it possible to get the rectangular area, and what is the maximum, not rectangular, squared area, and what's the maximum squared area that's obtainable in this setup? And it turns out like the maximum one is either this one, 1, 3, here 3, and then 4. Let me do this. 3, here 3. Or and 4. Maybe the other square is also valid, is like a lower one, but the area for the first one was 2 by 2, and for the second 2 by 2. So the answer should be 4 in this case, the maximum square area. And then the answer may be large, and in this case I should return 10 to the power of 9 plus 7. So the idea that how I gonna solve this issue is like basically I gonna have like I'm gonna save V delta like for all fences I have, for all fence combinations I have, all different V deltas. I'm gonna save all different V deltas. By how I gonna do that, I'm gonna have like 2 pointers I and J. I gonna start from 1 up to 3, and then J gonna start at 2 and up to 4. And then I'm gonna check, okay, what's the delta between 1 and 2, it's 1. What's the delta between 1 and 3? It's 2. What's the delta between 1 and 4? It's 3. And then I'm gonna move the pointer I to the next one. So it's gonna be delta between 2 and 3, 1. Already have 2 and 4, 2. And then the next one, so I have the set of delta 1, 2, 3, 3. And then I need to check the vertical, all horizontal deltas. And then if there is a match between vertical and horizontal delta, it means that, okay, I can have a square space by removing some of the vertical and horizontal bars, so like fences here. And in this case, I'm gonna have size 1 and size 2. So like the 1, 2, and 2 is matching, so the maximum result is 4. So the idea is like to go first plan, save deltas, or like let's call it V deltas to set traverse, and second one traverse H deltas if delta is matching, update area, or like max area, and then the third one, return max area. So the time complexity here gonna be n squared, or like how many we have here? Oh, it's m squared. So here gonna be m squared. Here traversal h delta, so it's gonna be n squared. And then the result gonna be m squared plus n squared. Gonna be all of this. And then it was time complexity, the space complexity. I need to save all the v deltas. So it's gonna be m squared of m squared. So that's it. I'm gonna start writing the solution. So let's say we have v let's call it h deltas. I'm gonna change it. Deltas equals set. Then for I in I'll also add h fences append 1, and then h fences append m, and then v fences append 1, and then the same v fences append n, and then for I in range len h, I'll go from range len h fences -1, and then for j in range range I plus 1, and then up to len h fences, and then I'm gonna have this deltas h deltas add, and then ups h fences I minus h fences j, and then I'm gonna do the same but for the v fences, and like check the max area. So the max area gonna be initially a 0, And then here gonna be max area, gonna be max area, and then here I need to check first if delta equal, okay, so delta gonna be equal h fences j minus h fences I, and here is ups, and then I'll check if h deltas, if delta in h deltas I'm gonna go update max area, and then gonna be delta squared. And then in the end I'm gonna return if max area not equal 0, else I'm gonna return -1, and here I'm gonna return max area divided by 10 to the power of 9 plus 7. So this is an algorithm for this problem. I guess append so here gonna be v fences h fences. So let me check like what's the problem here. Let's print h fences, or like h deltas. Okay, v fences here, v fences, and here v fences. No? Still no? So here, if I go h fences, and then if I print the v fences, it's gonna be there. Two, 1, 3. Let's check v fences. V fences 2, 1, 3. Okay, let's call it print. Format delta, and then here delta. Delta 1. Okay, then why it's not updating? Oh, max area squared. No, max area is squared actually here. Ah, I got it. So it's something like this. Okay. Okay, that's it. Yep, that's it.